Hi, I am Yusuf Dalva. Today, I will present you FluxSpace, a flexible image editing method to perform text-guided editing with rectified flow transformers. FluxSpace is a work accepted at CVPR 2025 and developed in GenLab at Virginia Tech, which is led by Pınar Yanardağ. We propose a training-free image editing approach for rectified flow transformers. By leveraging the internal representations of the transformer blocks within rectified flow transformers, we are able to perform the edits in a disentangled manner, while also preserving the generation quality of the model. We address two different sets of representations within the transformer blocks. This way, we are able to achieve both coarse level and fine-grained edits with a unified approach. We target the dual stream blocks within the rectified flow transformers, such as Flux. In editing, we perform two types of edits which are classified as coarse level and fine-grained level. While we target the modulation layers for coarse level edits, we utilize the outputs of the attention layers for the fine-grained edits. As we perform both of these edits in a unified framework, we can benefit from the strengths of the two sets of representations. To perform the fine-grained edits, we edit the outputs of the attention layers, which are the building blocks that form the image content gradually. To ensure that we modify the image while staying faithful to the original content, we project the attention formed by the edit condition onto the unconditional attention, considering it as a basis for the original image content. This gives us the attention component that is entangled with the attention formed during the generation. Utilizing this projection, we extract the attention component that is disentangled with the image content. To do so, we subtract the projected attention from the attention formed by the editing prompt. This new attention representation gives us editing features that can be added on top of the original attention output, while preserving the input contents. At the last step of our fine-grained editing scheme, we use the attention representation from the second step and use it as an editing direction. With a fine-grained editing scale, FluxSpace can control the strength of the edits with a positive or negative editing scale. For the coarse level edits, we target the modulation layers of the transformer. Instead of the token level inputs, these layers utilize clip embeddings along with the time step and guidance scale information. To utilize this building block, we edit the input clip embeddings with the same mindset. As the first step, we again extract the disentangled direction in clip space with orthogonal projection. Within the embedding space, this serves as our scalable editing direction. To preserve the properties such as scale of the embedding space, we implement the edit as a linear interpolation between the base condition and the editing condition. This way, we introduce another control point over the edit, controlling the effectiveness of the coarse editing. To aid the editing process, we utilize self-supervised attention masking on the attention outputs. Since the core component of our editing scheme is edited attention outputs, we introduce a mask-based control to suppress the pixels that receive low signal by the editing prompt. To do so, we utilize the layer-wise image text attention masks and construct decision boundaries that suppresses the low confidence latent pixels. Such a masking approach is shown to be beneficial for fine-grained editing, which improves the disentanglement properties of our method. FluxSpace is able to achieve face-targeted edits, where identity preservation is a major challenge. As we demonstrate, our approach can successfully preserve the input identity while generalizing over a variety of edits. In addition to portrait images, our approach is able to perform edits on domains such as scenery, cars, animals, and on-the-wild images. As we utilize the capabilities of Flux, our approach is able to generalize over a variety of edits without any additional guidance. The effectiveness of FluxSpace is demonstrated in the task of semantic editing over a variety of competing editing approaches. We evaluate our approach across a variety of metrics such as prompt alignment, identity preservation, and perceptual studies. As our final remarks, we propose FluxSpace in this study, a flexible approach to perform coarse-level and fine-grained edits with a controllable editing scale. By leveraging the generative capabilities and the internal representations of the rectified flow transformers, our method can perform disentangled edits while preserving the generative capabilities of the generative model.